Math 3, Unit 2, Section A. And so we're first going to talk about some definitions of terms. So a function is increasing on an interval when its y value increases from left to right, just like reading a book. Same thing, it's decreasing on an interval when its y value decreases from left to right. A function is constant. When do you think a function is constant? When the y value remains what?
Same.
The same. Okay, a relative minimum is a point where the function changes. So, for instance, this is a minimum point right here. And if you notice right now, it is decreasing and then it changes from decreasing into increasing. Okay, this right here is a relative maximum, and this one right now, it is increasing and then it changes to decreasing. A lot of this section we're building upon knowledge that we had from Unit 1. So if you are missing some of that knowledge, we're going to have to work on it and hopefully get you up to speed here for this unit. Okay? Again, no side conversations right now. You guys really need to focus. Okay? All right, so it says state the open interval on which f is increasing. Okay? An interval is when we're looking at our graph going from left to right. Okay? And so where do you notice it's increasing from? So if we start at the left, is this increasing from here up to here? Yes, right? We're reading it from left to right, it's going up. Okay? And so that would be negative infinity, if I can write this correctly, negative infinity. And then where does it stop increasing and change to decreasing? At what value? Negative 1. And this is not going to be a bracket, it's going to be a parenthesis. And the reason is that at negative 1, when it's changing from increasing to decreasing, it's not increasing or decreasing. Does that make sense? It's like at a set point. And so whenever you're talking about increasing and decreasing, you're always going to be using parentheses. Okay, no brackets on this. Do you see another point where it is increasing? So here all of a sudden it goes down, and then right here it starts increasing again, doesn't it? So what would be that interval? From which value to which value is it increasing? Positive 1 to 7. Yeah, so when you're talking about that, yeah. Okay, so where is it decreasing? When does it start going down? So where, right here, where does it start at? Negative 1, and it goes to 1. Okay, good. Okay, questions so far about this? Okay, domain. State the domain and range. We should be able to do this. We did this all back in Unit 1. Okay, so what is your domain of this function? I'd like you to go ahead and write it down. Okay, who thinks they have it? You want to share? Very good. Negative infinity all the way to positive 7. And is that going to be a bracket or a parenthesis? It's actually going to be a bracket because it actually equals at 7. And when we're talking about domain and range, we'll use our brackets and parentheses because it is an exact value. Okay? If it was a parenthesis, this would have a what? Open circle. Good. Okay, range. So ranges are y values going up and down. So what is my smallest range value? All the way down here, and what that is negative infinity. And the largest range value, where does it go up to? Positive 4. And is that going to be a bracket or a parenthesis? Bracket. Okay. Questions? This one right here? Okay, so if you're looking at this, do you see how when you're reading it from left to right, how it's starting down and going up? So that is an increasing function, and same from here to here. See how it starts down and it goes up. And so from this is negative infinity to the -1 value. And then this was at 1 to 7. So we are just stating the intervals in where it's increasing. And then this is the only point on the graph from here to here that it's decreasing. Is that better? Okay. All right. So state the coordinates of any relative minimums. Just so you know, relative minimums will not be starting points or ending points. It has to be within the graph. Okay? And so where do you see a minimum point? And I kind of mentioned this either, but right here, this is a relative minimum. So we're going to end up having these graphs, and any points that are down are relative mins. We're going to talk about absolute maximums and absolute minimums, but right now, relative maximums and minimums are just specific points on the graph that are either maximum values or minimum values. So this right here is a minimum value. Okay, so what order pair is that? Good. Okay, and so do you see how this is an endpoint? That is not going to be a maximum or minimum. Okay, we don't know how the graph would end up changing after that. Okay, so the only relative maximum on here would be at which point? -1,4. Good. Okay, any questions on either one of those? Yes.
So it's the only neighborhood that's visible on the graph that is one.
Exactly.
Would the quadratic have any relative minimums or maximums?
No.
Okay.
Just the specific points on the graph that are not like an ending.
Okay.
Okay?
All right, the quadratic.
All right. Okay. So now it says write a two piecewise function. And again, this is what we did back in Unit 1. Okay? Eyes up here. Back in Unit 1, we wrote piecewise functions. Okay? Some of you are struggling with that still because I think that when I talk, you guys don't listen. Okay. So, can you guys tell where these functions would end up separating? Where they change? Do you guys agree that the changes right here? What kind of function is that? This to the left. Quadratic. Okay, so we're going to go ahead and try to write the equation for this quadratic. Okay, and that's y equals ax squared is like our generic form for a parabola or a quadratic function. You getting this, Alyssa? Okay, so what is my vertex for this quadratic right here? -1,4, do we agree with that? That's at the point -1,4. So if I'm plugging that into this equation, we would write that as y equals a, and then it's going to be what inside? X plus 1 squared, and at the end we have plus 4. So remember, whatever goes in parentheses is the opposite. I'm going to move this up here for just a minute so you guys can see it better. Okay, now I put a there because with parabolas, unless it's like 1, 1, we really need to plug in points. Okay, and as you can see here, like how it's going, it might look like it's going 2, 2, but it's not really. And so we need to pick a point of the parabola to plug in to solve for a. So you can't pick your vertex, so we're going to choose this point. Okay, and what is that point? Okay, so we know that point is 1, 2. And so we're going to take this 1, 2 point, which is your x and y value, and we're going to plug it into this equation and solve for a. Okay, so we have 2 equals a, and then 1 plus 1 squared plus 4. Okay, so what's 1 plus 1? 2. And then 2 squared is 4. So I'm going to rewrite this as 2 equals 4a plus 4. And then we subtract 4 to both sides. negative 2 equals 4a, and we divide by 4, and when we reduce, what does a equal? Negative 1/2. So we're going to go over here, and we're going to write our piecewise function. Okay, and so we do that as f of x equals, and then we have our brace. So for our parabola, my equation is, we're going to take this negative 1/2 and plug it in for a. So we'd write that as negative 1/2 parenthesis x plus 1 squared plus 4. So I just have this equation that I already wrote, but I'm just substituting in the negative 1/2 for a. And then we have if, and what do I write for my domain for this function? There's a couple ways of writing it. I'm going to write it right now as x is less than or equal to 1. Okay, because right here, this is where the parabola starts, right? So it's all values less than or equal to 1, and it's drawn that way. And we also talked about last unit how if we wanted to, we could end up kind of like highlighting a line or something right here so we can see where it's changing. Okay, do we have a question on the parabola function and how to write that? Let me move it up again here. Yes.
X is the one because
Yes, so when you're writing, you're using your x values to know where you're marking in your function. Okay? All right, any other questions here? Okay, so we have to write the other part of the function, which is this line. We write lines in the form y equals mx plus b, correct? So I need my slope. Can you figure out what the slope is of that line?
Yeah, rise or run.
Rise over run. How many does it rise up? 2, and then right. So 2 over 6 reduces to what? 1/3. So I have y equals 1/3 x plus b. Now, this is my y-axis. I can't tell where this is crossing. And if you were to like draw this, you can see that it would end up hitting the y-axis at a fraction. Okay, so what can I do in order to find my b value? A lot of you mess up on this on your test. How can you find b? What would I need to do to find what b is? Plug in a point. Could I use the same point 1, 2? Yeah, so let's use the point 1, 2 and plug it in here and solve for b. Could you have also used this point over here? Yeah, but it's going to give me bigger numbers, and so I always like to choose whatever's the smaller numbers because then I have less to reduce. Okay? So we get 2 equals 1/3 times 1 plus b. So I just have this equation, and I took the point 1, 2 and plugged those values in for x and y into the equation. Are we good with that? Okay, what is 1/3 times 1? 1/3. Okay? Oops. Okay, and then in order to get b by itself, we would need to subtract 1/3. Do you know what 2 minus 1/3 is?
1 and 2/3.
1 and 2/3 is correct. Does anybody not know how to do that? Okay, so there's a couple ways of doing this, but if you have like a whole number and then your fractions, kind of think of them in different columns. Okay? So in order, it's like I have to borrow. So I change the 2 to 1, and then I would make this 3 over 3. Because 3 over 3 is really 1, right? And 1 plus 1 makes 2. Okay? And then when you're subtracting fractions, you're just taking your top numbers and subtracting them. So what's 3 minus 1? 2, and you keep the same denominator, and then 1 minus nothing here is 1. Okay, you could also think of like 1/3 plus what would make 2. You can think about it going backwards, but are we okay with that being 1 2/3? Okay. So now I can write this equation. Okay? So over here, our equation is going to be 1/3 x plus 1 2/3. Because that's my b value. If, and then what would we put there for my domain values? So do you see here how there's an endpoint on this graph? So whenever there's an endpoint, you have to do it where you have like the 2 numbers with the x in the middle. So the smallest value on this part of the function is what? 1. And so I'm going to go 1 is less than x. And I couldn't do less than or equal to because basically it can only be equal to 1 for one of the functions. And since I made it equal to 1 for my parabola, I can't have it equal 1 here. Okay? And so a lot of you forgot that too, but you can only have the equals 1 on one part of the graph. And then less than or equal to, and then what's that last value? 7. Okay, and so that's my piecewise function. I counted from point to point doing rise over run. So it went up 2, and then right 1, 2, 3, 4, 5, 6. Any other questions on this one? Okay, let's go ahead and turn the page. Okay, so I kind of want you guys to try this one on your own a little bit first. So starting with A, I'm just going to give you about 10, 15 seconds to state the open interval in which f is increasing. So looking at the graph, do you see the interval where it's increasing? When you're reading left to right, where is it going up? Where is it increasing?
0 to 2.
Good, and this is right. This is the only point on the graph when it's increasing. Okay, and that interval right there is from 0 to 2. So do you see how here it's going down, here it's going up, here it's going down, and here it's staying constant. So the only place it's increasing is at that point. And that interval, you're always looking at your domain, is from 0 to 2. Okay? So now there's a couple places where it's decreasing. So I'll give you a minute to write down, where is this graph decreasing? Okay, check in your group, see if you guys agree. Okay, and when you're writing your domains, remember that you're also going left to right. So you're starting at your smallest value. So right here it's decreasing from -4 and it decreases all the way until it gets to 0. And then we can do the U for union, and I could have done that on the other problem too. If you forget the U for union, it's not the end of the world. But here it increases, so that's not decreasing. And then I get to this point right here, which is at 2, and it's increasing from decreasing from 2 to what?
6, 4.
4. Okay? Because then here, do you see where it says, when is it constant? It's constant, it's staying the same. Constant means staying the same from the interval 4 to 6. Do you see why that is 4 to 6? Do you see how that's constant? Let's see. So 1, 2, 3, 4. Right? Yeah, no, so you have to use your x-axis, what values those are at. Okay? Okay, do we have any other questions about this one? Okay, can you guys state the domain and range? Starting with the domain, your x values. Good. Bracket or parenthesis? Bracket. So -4 all the way to +6. Okay, and our range. What's the smallest range value? -6. If you go all the way down, the smallest range value is way down here, which is at -6. And then it goes all the way up to +1. Okay, E. It says state the coordinates of any relative minimums. So what would be a coordinate of a relative minimum? Good. 0, -5 is correct. And what about a relative maximum? Where's a maximum point? Two, -2 is correct. Okay. Questions on any of that? Yes. -6. Minimum, like a relative minimum, or is that what you're talking about? So right here, it's at, hold on. 1, 2, 3, 4, 5. That should be 0, 5. Is that what you're talking about? Or down here? Okay, so this is not a relative minimum. And the reason is that when it's a relative minimum, it's going to be changing from going, so it's going decreasing and then it changes to increasing at the same point. And so do you see how here then it just becomes constant? So that wouldn't be considered a relative minimum.
Oh, so, okay, so it goes from decreasing to increasing. That's why the quadratic didn't have one in the last problem.
No, it did. It did at that point.
Yeah, it did.
Just at the point, but not where, because the parabola just goes, forever. But then it stops at that one point, but it didn't. That's when it changed from minimum to a maximum. So this point was a minimum, and that point was a maximum. But there's no change over here. And there was no change there. Okay?
Alright, we're gonna need a graph to keep time for that
So you have minimums and maximums when there's a change from increasing to decreasing or decreasing to increasing. But if there's no change, if it only stops, that's not a maximum or minimum. Okay? All right, or relative maximum or minimum. All right, so this says a three piecewise defined function. Okay. There's more than one way that you could split this up, but I'm going to split it up this way. So we're going to draw a line here and a line here to separate the three graphs. You could have drawn a line here and done that as an absolute value function, and then this line and this line, but we're going to just do it this way. Okay? So the first one we have is a what? Linear line. Lines are in y equals mx plus b form. Okay? So what is my slope on that? It goes up 1, 2, 3, 4, 5, 6. And it goes left 1, 2, 3, 4. So what does that reduce to? -3/2. Everybody okay at the slope? Was that a no? Slope, you pick 2 points on the line. You can see I have 2 points already written there. Your top value is your rise. So from here, it goes up 1, 2, 3, 4, 5, 6. If you look at your paper and you count, okay, when you're doing your slope, you're going from here to here. That's your slope, okay? And so from here to this point, it went up 6. And then from here to here, it went left 4. And that can reduce. 4. Okay, from point to point, it's 1. You're looking at units. Are we good? Okay. All right, so now we need to find the B. How am I going to find the B? Plug in a point. What point do we want to choose? I'm thinking This point, which is at 0, -5, is probably the easiest, but you could choose either one. So my point I'm going to choose is 0, -5. And so let's go ahead and write our equation. So we're going to have -5 equals -3/2 times 0 plus b. And actually, I didn't even have to plug in a point, did I? Because isn't this already on the y-axis? But it works out. You can see how plugging in a point, -3/2 times 0 is 0, and so you get b by itself, which is -5. So when we're writing our function, my first equation is going to be -3/2x minus 5 if, and what is that boundary? -4 is less than or equal to x is less than or equal to 0. Because this line is going from this point to this point. And that is from -4 to 0. Okay, so now we're going to do the second one. That's an absolute value function. Okay, absolute value functions are y equals a absolute value of x. What is the vertex there of that absolute value function? 2, 2. Right? Thank you. Candy. Okay, so we're going to plug that into our equation. Can I move this up here for a second? Okay. So 2, -2. So we have y equals a, and in my absolute value it'll be what? X minus 2 minus 2. Again, we need to know a point on there in order to find our a value, because it's not exact on there. So the point I'm going to use again is my 0, -5. So I plug in 0, -5 for x and y. We get -5 equals a absolute value of 0 minus 2, and then minus 2. What is 0 minus 2? -2, but when we take it out of the absolute value, it becomes a positive 2. So I have -5 equals 2a minus 2. We add 2 to both sides. We get -3 equals 2a. And then I divide by 2 to get a equals -3/2. So now we use both of these pieces and we write it. So it's going to be -3/2, absolute value of x minus 2 minus 2, if, and then what's the interval? 0 is less than x, because I can't have the equal to twice for the same number, is less than or equal to which value? 4. My last one is a straight line. What is that value for y? -6. If 4 is less than x is less than or equal to 6. Oops. And that's your function. Okay, so we're running out of time. I guess you can't see your tests. I'll show them to you tomorrow, but you guys want at least your progress reports? How about if I call your name and then you, well, actually, if you guys just kind of, well, if you want to do whatever you want to do. I already handed it out.
I know, the working math for unit 2, question 1.
Yeah, that's your homework.
Okay, for today.
Yes. And that's on your homework log.
Alright.
Okay, so let's see here. Tobiah, Brandon. If you want, I'll give you your stuff if you want. So Brandon, here's yours. Abigail, Noah, Jonathan, Abby, Ashley, Danny, Anthony, G. Maurice, you probably don't need yours. If I called your name, it's there. Okay, Jen, Corinne, Ethan, Josh H, Dominic, Devin, where Devin is, Austin, Mackenzie, Hannah, Alyssa, Marin, Leslie, Joseph Gonzalez, Tyler, sorry, Jacob, the other Jacob H, Peter, Zachary, or Zach, the other Joseph, Tiffany, thank you, Jacob P, Jimmy, Cameron, sorry,
Okay.
Troy, Noah,
Should I take?
Tiger, sorry.
Should I take my progress report?
You sure you can.
Okay.
Okay, guys. You three and Brandon, Josh, come here. I want to talk to the five of you. Okay. I feel like you guys need to be separated. Like I was like so disappointed at the work that I saw on your test. Like it seriously, like I was angry when I was reading your tests. Okay, Brandon, are you listening to me? Because this goes to you too. Do you think I should just move you guys, or do you guys feel like you want another chance and you want to do it better?
One more chance.
If you think you need to be moved, you tell me. But I, like, this is, oh my gosh, we're still recording. I'm so mad right now. I don't even know